In this video, we're going to look at how to do paired samples t-tests in R. I'm going to cover how to do it in long form and wide form data. There's been some recent changes in R regarding paired samples tests. So this is an updated video. You may have seen a paired samples t-test video in the past, but this is based on some new updates in R. We're going to use a couple of packages. To get the effect sizes, our Cohen's d, we'll use the effect size package, and we're also going to use the rstatics package later on. That's just going to show us an alternative way to do our t-test. So I'm just going to make some simple data here, and the first way I'm going to look at this is by using wide form data. So let's create that data. What do I mean by wide form data? Well, let's have a look at the data itself. The data set is wide essentially, so we have our subject here 1 to 10, and here's the scores on, let's say, a questionnaire before and then after a manipulation. So it's wide because the data is going across horizontally. Now, so that's our data set, and we want to compare before and after scores. Now there's several ways we can construct the code to do this. We can use this formula interface here, and we can just say t-test, and then we use pair. So we've got this pair function here, and in brackets afterwards we tell it what our two pairs are. And then we have tilde1, which basically means no groups, and then data function here, our data equals our wide form data that I've made there. So we tell it what our pairs are, no groups, and then where the data frame is, and we run that, and there we go. We get a paired samples t-test. We get our t-statistic, our degrees of freedom, our p-values, our confidence intervals, and our mean difference. Instead, what we can do is we can pull in the vectors here and say we've got data from our data wide we want before, and from our data wide we want after, and then tilde1 again. So all we're doing, instead of saying data equals wide using the formula method here, instead we are pulling in the specific vectors. So we're pulling it out of the data saying we want this, compare them, and we put tilde1 again. So if we run that, it'll give us exactly the same set of results. What we can also do is this sort of vector method here, where we're pulling out from data wide before, data wide after. We can also run the t-test in this way. So we put in those two vectors, data wide, data after, and instead of using this pair function, instead we can just simply say paired equals true. So if you run that, it will give us exactly the same results as before. So it's doing us a nice paired sample t-test. Now, sometimes people start going, oh well, therefore, by that logic, from what I've seen above, this should also work. Before, after, data equals wide, and paired equals true. However, this will not work. Okay, this formula method will not work if you want to use paired equals true. So if I try and run that, it won't work. Okay, so we don't want to be try and use that. So any of these three will do, depends what you're most comfortable with. I quite like using this method personally. Paired equals true has some issues later on with long form data. So any of those methods produce the same results. We can also get an effect size as well. So commonly you would report Cohen's d. So to do that, we use effect size and use the Cohen's _d function. And again, we can do this in different ways. So we can use our vector method like we used before with paired equals true. So if we do that, data wide before, data wide after, paired equals true, we get a Cohen's d. Specifically, it gives us Cohen's dz. And now we could also use this version of it, which is just the same as what we use for the t-test, Cohen's d, and then use our pair function, data wide before, data wide after, tilde1. So it's exactly the same as before. We can run that, and there we go, it gives us exactly the same results again. Now there is another form of Cohen's d, Cohen's DRM, Cohen's d repeated measures, and we can get that from the effect size package as well, but our function is repeated measures d, and we can just put in our two vectors there, data wide before, data wide after, and there we go, we got our Cohen's DRM. Now these are different calculations. I'm not going to go into the details on this here, but I've given you some information here, and also if you want to read up on about this, there is a nice paper by Daniel Lakens, which I've put in here as well, so you can look at that as well if you want to get more information on using the different Cohen's d. Now, we can also have long form data. So this code is going to create the same data set but in long form. So let's run that and let's have a look at our long form data. So what we have here is we have our subject, the condition, and then a score. The subject, you'll see, appears twice in this column. Once for before and once for after. Here's subject 1 before score, subject 1's after score, and so on. You used to be able to just tell it the independent variable, the dependent variable, and say paired equals true, but that doesn't work anymore. That has been removed from more recent versions of R. So we've got to try and approach this in a different way. One way that we can do it is simply create two new vectors which we'll call before scores and after scores. So we're going to pull out and make some small columns. Essentially, we're going to have a column or a vector that's just sort of floating in R, which is the before scores, and then we're going to have another one which is the after scores. So what I can do here, I'm going to create my new vector. It's going to be called before scores. I want R to go to my data long score column, and I want you to extract the scores if this is met. If in the data long data set condition is exactly the same as before. So this is telling it to pull out things out of the score column if the condition column says before. So if we run that, let's just have a look at our scores. There we go. So this is our vector here, and what have we got? We've got our scores 61, 62, 70, 60, 64, which are just these scores here: 61, 62, 70, 60, 64, 59, etc. And then we do exactly the same thing for after, except obviously we pull out those which the condition is after. And again, if you want, you could look at them. And here's our after scores. And then simply we can do our paired t-test on it. We can use different methods of doing this, but let's just use our pair function, and we can just say before scores and after scores, not sitting in data frame anywhere. We don't need to tell it where to find these. We've just got these vectors now, so we can just say t-test before scores, after scores. Let's run that. And there we go. We get exactly the same results again. Again, we could do our repeated measures D for this, before scores, after scores. And we get our repeated measures D. Now, there is another thing that we could do. We could use our statics as well if our data is in long form. It'll still allow us to do this. We need the R statics package pulled out of our library, and then we say t underscore test, so it's a different function, the R statics function. Here's our data. We've got score tilde condition, score predicted by condition, paired equals true. Detailed equals true just basically means that you want a full output from this. It can do a shortened version, but the full one's probably better. And here is our t-test output. Here's our test statistic, our p-value, our degrees of freedom, and we get confidence intervals as well. I just don't particularly like this as an output personally. We can also get an effect size with this long form data. Now, you'll know we have to use the R statics version of Cohen's d, and you'll see it's called Cohen's d and effect size as well. So R will get confused because we've got two functions from different packages with the same name. So we say R statics colon. So specifically from R statics we take the Cohen's d function, and then we use similar as before. It's the data long, so we want our long form data, score predicted by condition, and it's paired. And we run that, and we got our Cohen's dz. Our statics will not do a Cohen's DRM. Now personally, I think the first solution I showed you is a better way of doing this, keeping it in base R as much as possible, and it gives you nice, clear, neat results for your output. But that's how you can do paired samples t-test, whether your data is wide or long.